So okay, I'll have to introduce you guys again. I'm sorry. Uh, we have Soham and Rahul joining us today. So Soham has been a GSoC developer and a mentor, and he's done a lot of different stuff. It's really, I mean, introducing him properly will generally take time. And Rahul, he's from Triple IT. And he worked as a GSoC developer at OpenAstronomy under SunPy. So these are the guys who are going to be talking today. And over to you, Soham.
Thank you for the warm welcome, Ayan. Uh, yeah, so I'll just present my screen. Let me know if it's visible. I hope my screen is visible.
Yes, it's visible.
Okay, cool. So this talk is going to be really interactive. I think most of the gist of what GSoC is, what open source is, and stuff would be given to you by Jugal and Amog yesterday. So I won't be talking about it much. I'll just be keeping my discussion short and succinct to topics that are relevant. So yep, this is what we'll be covering today. Main points. I'll give a brief background about myself, discuss what project I worked on in GSoC and how it's relevant in the real world. Secondly, since I've been a mentor at both Kubernetes, that is CNCF, and Outreachy at Wikimedia, I'll just give a gist on how we evaluate students, how I was evaluated, and also like what GSoC is, what GSoC isn't, and yeah, last would be the questions that you have. So let's jump right onto the actual thing. So a little bit about me. I think Aryan already introduced it, but just a gist. I am Soham. I am currently in fourth year, planning to do my masters. I am outreachy mentor at Wikimedia for this winter round. I've also been a GSoC student at Wikimedia, and in the past, I've also been a co-mentor at CNCF. I was invited to become a mentor, but since I was also selected as a student, I thought that would be better for me to take than to be a full-time mentor. So I just decided to co-mentor. Yep. So this is just a bit about my project. It's really complicated, so I'm not going to dive too much into it. But my project was majorly about evaluating three end-to-end testing frameworks: Puppeteer, Cypress, and Microsoft Playwright. I'm not sure if you would know about this or testing in general, so I don't expect you to understand any of this. But the only highlights that I would give from my entire project was like it mainly involved evaluating this with their existing testing framework in terms of parallelism, how customizable it is. Are we able to record videos on the CI? If not, how should we add that feature? Which led me to contributing to Jest. Jest is basically a testing framework that is maintained by Facebook. And WebDriver is just a Selenium based open source framework in JavaScript. I contributed to that as well upstream. And yeah, a lot of Docker. I broke CI thrice. And yeah, they have a token for that. They have a T-shirt for breaking Wikipedia. I think that's a mistake on my part. And yeah, just in general, this is the stuff that I worked on. It's really complicated, so I won't get too much into it. But in general, it's just related to DevOps. And just to give you a brief on what DevOps is, basically DevOps is a full form, is a short for developers dash operators. So earlier on, we used to have developers working in separate teams as operators. Operators are people who are like of deploying the project on the large scale, and developers are the people who actually design the applications. So the thing about DevOps is it's a very broad field and it's a very important field, because if you don't have deployment, you can't actually leverage the app that you've built to on a large scale. Uh, you can look into it on Wikipedia. It is a really broad term. I can't define it in one go, but it's just a brief background about me. I'll just focus on why it's important. So why should you care about DevOps? Like, how was my project related to real world? So like I said, the first thing, you make an app, you do all the ML stuff, all the cool stuff at the back end, design a chatbot or whatever you're into. But then there's always this question, right? How many people at a time are going to be able to access your app? If it's like a huge number of people, your site will just go down. So you need to maintain that somehow, right? That's where DevOps come into picture. There is load balancing, there is cross network trafficking, proxying, a lot of stuff that happens behind the scenes which takes care of this server load. Like, you don't want your servers to be at any given point in time down. you always expect services to be constantly available. Like, as an example, just imagine if Google was working on their website and they took down Google search engine itself for that period of time. Like, would you use that search engine again? Like, personally, I wouldn't. I don't use Google for privacy issues, but even if that was the case, I wouldn't use Google again if they followed such a practice of taking down their entire environment just to introduce new features and stuff. I always expect them to be constantly available. And that's what DevOps allows you to do. It gives an application complete availability. Second, writing automation cannot be automated, at least not now, right? There are things like MLOps and stuff, those are innovations. You write the automated script itself using machine learning and stuff, but it's a long way. It's a far journey, right? It's a long journey. So we are not there yet. Might be in few years from now, but right now at least not. So these part are something that this is an area which is going to be free from recession or automation, fear of automation or AI taking over for a very long time. As long as you have apps, DevOps is going to remain there in some form or the other, and it needs to have some sort of human intervention. Latest and greatest. So, yep, all organizations dig Docker, Kubernetes, Elasticsearch, Prometheus VMware, Hypervisor. These are just few tools which are used in DevOps. You don't need to understand this or get into it, but these are some buzzwords that you would come across if you're dealing with DevOps in general. And my last thing is don't fit square inside a circle. So this is related to selection of a GSoC project or any project as a matter in any open source like in any open source event that you take part into. So I've personally been doing ML since a long time, since past 3 years. People were doing stuff like Android and web development and whatnot, but I was pretty sure with what my interests were, and I really started with a bang with machine learning. I was good at math, so it really stuck well to me. But like, yeah, I'm in the same final year project as Ankit is, and he'll tell you that we can't fit machine learning in everything. There are some places where even if you want to fit machine learning, it's just not a good choice because maybe you don't have enough compute, or you're not ready to still scale it to that extent, or you're not confident about the evaluations and accuracy, and the risk is just too high, right? So my like it's just a general suggestion. Most people I've come across tend to follow machine learning blindly. They don't have any idea about the math underneath. They just go for the buzzwords, learn a bit of scikit-learn and stuff. Machine learning is just math and somewhat some sort of statistics. But like, if you are someone who is not into research and who feels that you just crack by doing an Andrew Ng course in the Coursera without reading any books, I'm sorry, that's not a place you want to be in. Even if you somehow scale and complete that project, you're not going to get a machine learning job. And if you see the statistics, most of the people who are machine learning engineers work in startups, but the actual work that's being done in machine learning is in the research and development department, like Google Brain and IBM Watson, just name it. These startups, you just be coding what someone tells you to, but that's what even software developers do, right? So yeah, it's just a suggestion. If you're someone following machine learning, don't do it for the buzzword. If you're not ready to put that research into it, it's just a waste of time. Just look for something else that interests you and just follow that. Everything is dependent on how well you do in that field, right? So yep, just a short advice. Okay, so now like this is like a backstage. So we discussed about my project in general and DevOps in general. So back I want to discuss, like we'll be discussing like how students are actually evaluated. So yep, basically if you it depends. Like, there are three components when we evaluate. Proposals are also there. I've not included that because they are a part of relationships. It's a really broad term, but previous knowledge is first. uh, I think people might have different views on this, but this is what I have learned so far. Is if the org is small, by small I mean there are like really limited number of projects and it's not that big of an organization in general on paper, or it's something like, if you have not heard of the org before, the chances are that it's just a small org, or it's just a small part of a big org. It can be either ways. CERN has a lot many subparts, like it's like a really big org. But in general, if it's a small org, this won't matter much. They won't expect you to know much. But if it's like a big organization like Wikimedia or CERN, you need to know your stuff well. I mean, I can't stress this enough. You just need to be really good at what you're doing, because the number of applications and the type of people that apply are insane. Like the competition is too much. So I can't stress on this enough, but if you're applying on a big for a big organization, you need to take a project which you have sound knowledge of. Like you cannot just apply in a place with a really faulty proposal without actually knowing what it means, because chances are you might not be able to even complete the entire project, and you'll just be missing deadlines, and ultimately like you'll be thrown out of GSoC, and that is something that happens not frequently, but it does. So just pick a project which you know about inside out. If it's JavaScript, pick that project. If it's Python, pick that project, but just know what you're going to be using. Second is perseverance. So this is something I get a lot. Like, how do you understand such a large code base? And my suggestion is, you don't need to know how the entire thing runs. Just focus on the part that you're going to deal with. Just focus on the section of your project. Don't focus on the entire code base. Like a project will not just involve, if it's a JavaScript project, it's like if it's a website, it's not going to just be backend code and front end React and stuff like that. There's going to be Docker files. There are going to be parsers, linters. You don't want to get into all those stuff, build configurations and stuff, but you don't need to know that, right? You just need to focus on specific part of your project. So if it's a large code base, chances are that you will be working only in a certain subpart. Just be really sure what you're going to be working with. Ask your mentors if you have any doubt, if you don't know, if you're totally lost. But like it's just a fact. We don't know either. Like we don't know the entire code base either. Like my project involved PHP and a lot of stuff, but I don't know PHP. So that's something I didn't bother with, right? And there are tests in PHP and whatnot. Like, so yeah, just stick to that part of the project that you're working with. Third is relationships. I cannot stress this enough. By relationships, I do not mean relationships as in speech and stuff like that. I'm not telling you to propose your mentor. This is not something that I'm recommending. I would recommend either. Chances are they're already married. But the thing is, like, most form of communication in these open source organizations is largely written. You need to be able to file good bug reports. You need to be able to file good issues, and you need to be really communicative. And for me as a mentor, there are chances where I review code. I need to take sure that I don't hurt that person's ego, right? When I'm reviewing and the person has done wrong, I can't say like, oh, you're stupid and you don't know how to do this, and how are you even writing your commit messages? I don't understand a thing, and your English is just hopeless. I can't do that, right? The person will just eventually stop respecting me at some point in life. So you need to be really communicative in a good way. You need to respect everyone, whether their views match your own or whether they don't. But you need to be really good at writing all this. You need to be really good at filing issues and bug reports. That's how these organizations basically run. They don't meet each other. They're completely remote. So unless you write properly, they're not going to know what's going on in your mind. If it's a bug, make sure that you tell them all the steps that you need to reproduce what errors you're getting. If you can't give them that, they're not going to be able to help you. Uh, so yep, this is just a bit on what GSoC gives you, like what you get out of GSoC or any big open source event like Outreachy. First is networking. Networking is the best thing you will get out of GSoC. Try to do this as much as you can, especially if it's a big org. You will get to network with a lot of people. Those people have worked with Google, they've worked with Apple, they've worked with I don't know what sort of crazy organizations, but getting in touch with these people and earning their earning their praise is something that's amazing, and that's something that GSoC gives you. On a normal everyday life, you wouldn't get that. So my mentor, he's from Croatia, and he's been into testing and DevOps since past. He's in my organization since past 8 years, but I don't know how long he's been into. But he basically built his own automation framework called Vatir, which once upon a time really rivaled Selenium. You don't need to know all this, but it's just know that he's really big shot. If you want to see how what my proposal was and how I applied to Wikimedia, I have written a blog post on that, so you can just check out that on my site. I won't go into much details, but yeah, you get to work with really great people. Second is visibility. You get immense visibility if you have GSoC or Outreachy tag on your profile. Recruiters are going to flood in your LinkedIn, and that is going to happen. But those would mostly be startups and fast track Google interviews. So yeah, this is true. Earlier they used to provide referrals, but now they don't. So if you have like a GSoC tag in your interview, they have a separate section for those type of applicants, and they do fast track some to some extent those interviews for you. I'm not sure how true this is for India, but for worldwide, other places, if you're applying to Dublin or something like that, this is something that's really true. But like I've seen people picture a really good painting of what GSoC is, but let me tell you, it's going to open doors for you, but not all, right? There are some things that you need to keep track of, and one of them is GPA. I know so many people who are doing such great projects, but they have GPAs like 7, 8. Morgan Stanley came this year with a cutoff of 9, and they didn't even make the cut, right? Not from our college, but in general, like they have a GPA criteria for 9. Even some organizations like Altation and Neutronics, they have really high GPA criteria. So even if they had this GSoC profile, and I have no clue what all they've done, but it was super good profile, like a super good TensorFlow. They worked with TensorFlow, and they worked with I don't know which all other organizations, but they didn't have the GPA, so they didn't even make the cut. They didn't even reach that stage where a recruiter could see their resume and say, "Oh, you've done GSoC. Tell me about it." So please, please, please maintain a GPA if possible, an average of 9. 8.5 is the minimum. You should have at least that. Second is publications. If you're applying for masters, I cannot stress this enough. Please, please, please focus on research. Do your papers, work under teachers, work on independent projects. You don't need a teacher to even file a paper. Just work and do your research really well. If you're interested in NLP, like look up the papers on Google Scholar, try to find an application of those, try to do some research on this, because that's what the professors care about. Chances are they might not even know what GSoC is until they Google it up. So I can't stress this enough. If you're applying for masters, please, please, please focus your time and energy on research. If you don't have GSoC, but if you just have like really good papers, you'll still get into. And our super senior Samishta, I think she's an example of that. She got into Georgia Tech, no GSoC, nothing, only through papers. And third is DSA. This is going to be everywhere, right? Even if you're a GSoC student, you have a lot of tags. Google just fast tracks your interviews, but you will have to give those technical rounds, those systems rounds, those machine rounds, whatever rounds they have. And if you don't know just think of this interview process as a mini gate exam, right? You need to know your OS, you need to know your database, you need to know your algorithms. I personally cracked Goldman Sachs internship last year and the job this year. I'm unfortunately not going to take this since I'm pursuing my master's, but I cannot focus on this enough. They're really DSA heavy. They are database heavy. They're operating systems heavy. I cannot stress on this enough. Please don't screw up your DSA if you're applying for a job. That is, it's really crucial. And these all things are something that GSoC won't give you. It'll give you an edge, but once you reach that stage where your edge really starts mattering, right? If you're not even going to qualify and reach to that stage, people are not going to even see you. So your GSoC won't matter then. And yep, so this is all that I have to say for today. I think yesterday people covered a lot of scope. So if you have any questions, please do ask. Uh, yep, that's it from my side.
So if anybody has any specific questions, then I think we can spend a minute or two here. But if not, then we'll have a proper question and answer session at the end, if that's all right.
Yeah, I'm fine with anything.
Okay, then does anybody have any questions? So you can put it in the chat section or just I don't think you can unmute yourself. Okay, so there's a question from Adnan. Please explain more about DevOps. Well, DevOps.
DevOps was a deliberate title. It's because our Cypress experiment was a failure. Um, anyways, so like I said, there are a lot of good resources on DevOps. You should check out Google's documentation for them. I'll try to link them later in the slides. I'll be sharing these slides for your reference. So you can just check out there. It's a really broad topic, and I think it'll take a lot of time. And we have like another speaker too. So I don't want to, with all due respect, I don't want to really get into that right now. But yeah, you can just Google it up in general, and you'll get an idea of what it is and what it's not. Any other questions?
ठीक है
I
फिर
guess.
yeah, so we'll go for so Rahul, you can now take over.
Thanks, Aryan. Thanks, Soham. And good evening, guys. So, cool. Let me share my screen. God damn it. I have to give it permission on Mac. Just give me a minute. I hate when this happens. Yep. This should work now. Uh, Let me know if my screen is visible.
No, not yet, not yet.
Is it now?
Yep,
Yeah.
Cool.
it's working.
I'm just gonna ignore that for now. And cool. So, yeah. So before I begin, as Aryan mentioned, I should give an introduction for myself. So full disclosure here, uh, I did GSoC in the same org as Amog. Amog invited me to give this talk. In fact, Amog was kind enough to make these slides for me because I'm too lazy to make slides, and I just told him that I was busy. I was, but still, I was too busy. And yeah, uh, I'm not what you would call your average programmer in the sense I don't resonate with programming or software engineering or anything. If anything, I'll say that I'm more into liberal arts, sciences, maths, literature, history. And that also explains why I went for open astronomy. So I have no clue about DevOps. I can't make a website. I can't do any of those things. I got into machine learning because that's more sciencey for me, and open astronomy because astronomy. So that's pretty straightforward. What I am doing right now is so after GSoC, I had my with another Sanpai GSoC mentee, Chris from Hong Kong. He and I started our own open source organization for wildfire data analysis. I'm a lead developer at that, and I'm also a full-time artificial intelligence research engineer at a startup in Seattle. So it was started by people from DeepMind, the same people from AlphaGo. And if any one of you have heard that Google was able to get the electricity bill 40% down on their data centers, it's the same team. So, and Soham mentioned a very nice thing that recruiters would flood your LinkedIn after GSoC. That happened with me. I got in through basically recruiters asking me to join their company. Cool. Also, Soham, just one thing. You've really scared me, dude. I don't have a very high GPA. My GPA is 8.2. No, 8.4, I guess. Anyway, so cool. I need to buck up. Let's get back to my project. So, what my project is. The title of my project is solar weather forecasting using linear algebra, which is a fancy way of saying solar weather forecasting using neural networks. But we're going to use linear algebra so that people who don't know about machine learning that well will not apply. This is actually the rationale behind this naming, and it's out there on SunPy's repository. They have an issue where they talked about it, so that's pretty cool. Yeah. So what are solar flares? Do you see these loops coming out of the sun's surface? These are solar flares. That's a very simple explanation. Yeah.
Rahul,
Yeah.
I guess the slide hasn't changed.
Uh, has it not even now?
I don't think so.
I think you
Uh,
shared just the window, not
Wait,
your screen. I
uh,
think.
yeah,
wait, let me try again.
that's fine.
Uh, is it changing now?
Yeah.
Cool. Sorry for that. Yeah. So solar weather forecasting using linear algebra, solar flares. These loopy things are solar flares. So a little physics background here. What solar flares are. So sun is a hot mess of plasma. The sun's surface has charged particles whizzing around in all directions. What happens when a charge is in motion is you get a magnetic field. Sometimes those magnetic fields form tubes. These tubes make the charged particles form loops around them. If you remember your 12th standard physics, this creates a feedback loop where you have charges moving in magnetic fields, and because the charges are moving, they create more magnetic fields. What happens sometimes is these regions, this black region, if you see it, uh, this blackness and the white region, they twist around each other. What that creates is in the magnetic field lines originating from the black to the white, there becomes a monopole. which cannot exist by physics. So you have this whole burst of energy uh, outwards, and that is seen by us as a solar flare. For example, this is my wait. Let me get a pointer. Do you see this thing? This white thing. This is a solar flare. These are sunspots. My task was to predict the frequency of solar flares based on magnetic field information from um, SOHO MDI Michelson Doppler imager, one of NASA's satellites, uh, which took the images of these sunspots. So TLDR, I have an array which corresponds to the magnetic field from a cross section of the sun, and I have to predict whether this sunspot would go boom boom. Mostly they don't, but sometimes they do. The real world application of this project is that, well, solar storms can pose a real threat to our communication lines, our satellites, our electric grids. It happened in Chicago a century ago, where there was a massive solar flare, so a solar storm, if you may, and that solar storm blew up the electrical grid. So you don't want that to happen. So the long-term thing is to be better able to predict whether there are going to be any solar flares or not. Cool. Yep. So this is an example of the data that I have. This may not seem very fancy, but this has all the information that we need. So as you can see, these are the active regions, the sunspots, and these come in all shapes and sizes, and sometimes very weird orientations as well. The black corresponds to the North Pole, the white corresponds to the South Pole, or it was the other way around, one of these. What we used was the sunspotter dataset. So this is the best example of humanity figuring out how to solve a problem. The scientists wanted to figure out whether the complexity of a sunspot is any way related to their flaring capability. Now, the problem with complexity of something is you cannot define it as a ratio. You can define it relatively, but not as a ratio. For example, if I ask you to tell me whether this sunspot is more complex than this one, you will be able to give me a vague idea of whether this was true or not. But if I ask you just about the complexity of an individual sunspot, you will not be able to tell me. So what they did was they got around 27 or 30,000 volunteers, and they asked them to grade which sunspot was more complex. So all the volunteers were given 2 images. They had to grade whether one was more complex than the other. So you have a lot of these pairwise matchings. Then they use an ELO ranking system, the same system that you use on chess. And I don't know whether it's also something similar used in competitive coding to assign user rankings. I think that's a little different, but yeah, in chess that's used. So that's nothing but normalization and Bayesian distribution of whether something is more complex inherently or whether it's just more complex because the other thing is very simple. So what we have is this range of numbers from, if I remember correctly, 500 to 3000, which gave you an index of whether an active region was complex or not. Cool. So my first task was to see whether well, there was anything there or not. And we were able to do a few statistical tests to see whether the complexity actually correlated to the flaring capability of a flare of a sunspot or not. And we got around a moderate positive correlation. So thereby we also proved that people didn't screw up, which is also, I was pretty surprised. I wasn't expecting it. The next thing was to predict it using your neural networks. I went for a vanilla CNN because the data set, in my opinion, wasn't that complex, and that worked well. We got around 80% accuracy, which is good enough. Like, it's on par with state-of-the-art methods which don't use machine learning. The reason why we couldn't go further than that is because the data is not image files, it's FITS files. FITS is something that NASA uses to send images and planar data across. It has both negative and positive values, and it does not correspond to pixel intensities. Secondly, they were of different sizes, so we had to do a lot of pre-processing. So a lot of information was lost there, And my mentor believed that without pre-processing, the pre-processing that we had to do, if we had received the raw data from NASA, it would have worked better. So we are thinking of expanding it later. Third was to remove noise, and I had used an autoencoder for it. So if you guys don't know what autoencoders are, just hit me up after this talk and I'll explain them. I don't want to go into specific architectures because you can easily go to Medium articles to figure out what these things are. Cool. So what the result was? The result was a search events object. Oh yeah, I forgot about this. So we also have a lot of catalogs in solar physics. Uh, Same thing observed by different observatories and different satellites. So although the data is of the same object, it's different because of different orientations, different calculations, different pre-processings and whatnot. So what you get is basically two tables with almost identical entries, but not exact IDs. And there is no foreign key. So you have no clue as to which row corresponds to which row. Our search image object basically used a few implementations from Topcat to see whether we could do some sort of fuzzy matching. Fuzzy matching is not the precise word here because fuzzy matching is done in strings, but still, it was just an imperfect matching. And we figured out that cosine similarity and Euclidean distance and basically an amalgamation of two worked good enough for us, and yeah, that's how we went. What we created was a general purpose search events object. So if you have any two observations from any two given scientific sources, you can get a unified table with match entries, along with some probabilities of the algorithm screwing up. And solar flare forecasting. Yay, we forecasted whether we're going to get our satellites ruined by solar flares or not, which turns out isn't really likely because, well, the sun is really benevolent. It won't screw up our satellites that often, but sometimes it does. And finally, my repository that I use for GSoC, Pythia. A cool story though. So my mentor wanted, in our first meeting, he asked me to name the repository something. His idea was to initially go with Sun ML and then go with it. And I straight away told him that I would rather die than give it such a boring name. It took me 2 days to figure out a cool enough name, and I chose Pythia. So Pythia in Greek mythology was the chief priestess at Delphi. She was the oracle of Apollo. So Pythia was the only human capable of knowing the moods and fancies and the temper of Apollo, the god of the sun. And I found a really good match with my project, so I named it that. My mentor really loved it. So, yep. I guess this is the last slide, and I think I should talk a little more about GSoC in general and the way to approach things. So, my experiences have been very different from Soham, and his experiences are like, I'm the outlier here, just to be clear. I've seen a lot of people go through similar experiences as he has. In my case, it was, I don't know whether I got lucky or whether it was just something entirely different. So I never did DSA. Like, I know basic stuff, but I never was heavily into your competitive programming. I'm 2-star on CodeChef, and the last time I logged in was 2018. Yeah. Uh, I do agree with him that you should publish more papers, but if you do it with the idea of getting into a good college for your masters, then your quality of the papers would not be that good, honestly, in my opinion, as far as I've seen. This is based on a lot of papers that I've seen come out of India, which are not up to the standards because it's mostly about publishing a paper rather than publishing something cool and something interesting. And lastly, about GPA, I have already mentioned I don't have a good GPA. To my credit, I do have a good GPA when it comes to math subjects, but I really screw up when it comes to compilers and all that stuff. It's boring. So how open astronomy treats students is, so I think the difference comes in the fact that most of the people in open astronomy are physicists and not directly software engineers. So those people really don't care whether you're a very good technocrat or not. I'll be honest, when I started contributing, and I started contributing very early for open astronomy, it was mostly related to GSoC, but also because last year, when I was in my third semester, I tried to join a lot of orgs. I stalked their IRC. I spoke to around 50, 60 people on LinkedIn. and I couldn't read code bases, and that was a very big problem for me. I tried TensorFlow, I tried MLPack, I tried all these things. In the end, I decided that, well, I'm not the software engineering guy. I would rather study history and study literature and philosophy than go for computer science. So might as well go with something that I really fancy. That was astronomy, so I went there. Uh, Even there, I didn't know how to use Git at all, or to code. Like I know how to code in Python. I knew how to code in Python, but not in the development kind of way. I could write basic programs, but nothing much. Uh, I was very lucky. I saw an issue where I had to change just the date time format of something. And this was the first time that I went to an open source organization and I opened an issue, a good first issue, and I could see what they were trying to ask the people to do. So that was a really shocking moment for me that, hey, I can understand this stuff now, Vice. So I made a PR. That too, I went to my friend and asked him to help me out with it because I didn't know how Git worked. And uh, in SunPy, we used to have something called SunPy bot, which used to tell you that if you ever made a PR, you should have a change log, which is nothing but basically telling what you did in plain English in an RST file. I didn't know what it was. I freaked out and I think I closed my PR because I was like, I must have broken something. But then I reopened it, and the mentors were really helpful to the point that in the end, after much discussion, they had to solve it on their own, the documentation fixed. But it was my first PR, and I was really proud of it. And it was really fun. 2 days later, I made the next PR. This time I did it on my own. Again, documentation fixes. I joined the IRC. Those people were really helpful. They taught me everything that I know about Python, everything I know about Git. And I have a good job right now, and I wouldn't have had it if it was not for those people and their kindness. SunPy in particular, I don't know whether Amog would agree with this or not because I don't remember which organization sub-org Amog was in, but I think it should be similar. So this is what my mentor told me, and he's basically the organization head for SunPy, for Open Astronomy, David. Uh, he said that they don't require people who know everything, and they don't even require people who are brilliant technocrats. Yes, if you are and you help them, that would be nice, that would be awesome. But they want people who genuinely love what they're doing. It may not be related to development, it may not be related to solar physics, it may just be, loving to explore things out. They want people who are consistent, they want people who can commit to being in an organization. The difference that I have experienced in open source development and anything else that I've seen is open source is not about money. It's not about jobs. It's not about anything. It's definitely not about jobs. You will get jobs definitely from open source, but it's not about jobs. What open source is about being passionate. It's about being that kid you were when you used to play with Lego blocks. It's just about building stuff and breaking stuff. And funny thing is, that's all people require. That's it's very stupid when you hear about this, but that's all people require. Just a person who's enthusiastic and who wants to do stuff. And I've seen a lot of people who fit into this category. A friend of mine, he is in PyMC. Same story like me. He has 9.5, so yeah, CGPA, so that's there. But he got into PyMC, and now he's working as a contractor with them, a freelancer with them in his mentor's firm. And he didn't know anything at that time when he started. Just he was enthusiastic about probabilistic programming, and he loved working with distributions, and that's all his mentor asked him to do. So yeah, if you take anything away from this talk is sometimes it's better to pause and ponder and ask yourself why you're doing stuff and whether this is the stuff that you really wanted to do. For me, that's really important. I should feel happy with what I'm doing, not just in the way of getting something out of it, just happy doing it. And that's when I do my best work, and I think that's when most people do their best work. So yep, I would like to thank Amog once again for inviting me, and sorry if I was a little too preachy, but I figured out that you guys already, so if you're in this talk, you already know about GSoC, you already know about what most organizations want. But what most people don't realize is at the end of the day, people want the person and not just a bot. Cool. If you have any other questions, I'd love to answer them. I'll stop sharing my screen now, I guess.
Okay, thank you, Rahul. I think uh, this was really fascinating personally for me as well because both of you provided really contrasting opinions, and it was really, I mean, this is a lot to contend with because, yeah, you really have to think about these things a lot, and I think you really put that. I mean, I don't know. I really liked what you said. So, I think we'll go for questions now. If anybody has any questions, there are actually, I mean, there's just 20, 25 of you. So, genuinely, if you just like, if I'll make it so that you can unmute yourself, and if you want to talk and you want to just have a conversation, I think that should be fine. We do have like quite a bit of time right now, unless, of course, Soham or Rahul have to leave. But if you I mean, feel free to just talk, and uh, we'll do, I mean, they'll do their best to answer your questions.
Hi, my name is Meg. I'm from DJ Sangvi only. So my question is, like yesterday we had a GSoC 101 where we got to know like what GSoC is and what open source in general is, what type of events are held for open source and where we can like contribute in open source. So after yesterday, I was quite interested to start my open source journey. And what I did was I was looking at a lot of GitHub repos, and I always used to go to issues. I used to find filter labels, and I used to take either help wanted or good first issues. So what I generally notice is half of the stuff I'm not able to understand. Like I filtered out a lot of things. I added my specific language that was JavaScript. I added tags that I'm learning Node right now, so I added all those tags. But still, I couldn't find my perfect repository to contribute to open source. In that case, what can I do?
Do you want anyone specific to answer that, or is it just up for grabs?
It's open to anyone. Like
Yep.
you guys know how to contribute, like the first issue or the first
Yep.
repo that you contribute to.
So, do you want to take that up, or do you want me to go for it?
I can take this up since I am also a JavaScript person.
Cool.
But yeah, like let's just answer whatever we have to offer. So personally, what I would recommend is it depends. If the org is really responsive, just clarify to them, maybe comment in the same issue if you're not understanding something, and chances are that someone will reach out to you and explain what they want. Like if they really want something to be solved, they are going to explain how it's done, and most of the people in many orgs are nice enough to do that. So even if there's something that you don't understand in specific, just ask them where it is that you're lagging, and they'll just guide you to resources and at times even help you out with PRs even if they're wrong. The only thing is like it doesn't matter if you break something, but you need to at least have a start. And if there's some place where you don't understand anything, you should definitely reach out the mentors or the org admins in that case.
And to add to his point,
Thank you.
I would also recommend joining the IRC. So that's the easiest way to get into the flow of what's going on.
Rahul, could you maybe just mention one line about what IRC is? I think we
Yeah.
glossed over that in our talk yesterday, but this would be a good point to just mention what it is.
Cool. So basically, IRC is a chat room where everyone doing work for the organization can come and discuss things. For Open Astronomy, we have the IRC on Matrix and use the Element client for it. So it's basically just like your WhatsApp group where you come and talk. Depending on how serious your organization is, it can go from PyMC level where they just have a mailing list where everything happens on the mailing list and there's no chat kind of a feature. You send emails and people respond to those emails. Or you can have SunPy level of openness where we have one dedicated off-topic channel just for memes and sending bunny photographs. So yeah, every org has an IRC because that's more convenient to discuss if you just want to talk to people. Ask on there. That's the best thing you can do if you don't know what to do.
Thanks a lot, guys. Thanks a lot.
And one more thing to, if I may. So I was in your shoes last year too, and I don't know about JavaScript. I'm more into Python. So I would recommend that rather than, so I did the same mistake as you are doing, according to me. So I filtered using Python. I went to PSF. I saw many different organizations that just use Python, but I couldn't figure out what to do. So what I ended up doing was, rather than going by the tools, I went by the topic. So don't go by the how, but go by the what. Uh, for me, it was easy to understand what the bigger picture was with open astronomy, because I could understand what they were trying to build. Not how they were trying to build, that wasn't clear to me, but at least I had the bigger picture that, okay, they want to analyze this photograph of the sun and they want to zoom in and they want to do some weird freaky uh, image processing on it. Okay, this is the part of the code where they're actually doing it. Nice. This much I understood, and then basically you just have to have a start. So if you could do that, that would really help you out.
Thank you.
Any more questions? Actually, I have a question. So, full disclosure, I'm applying for GSoC this year as well. So, I've been listening attentively to everything all of you just said. So, both of you just said. So, my question is basically that for an organization like SunPy, that's definitely something that would require a specific level of domain knowledge, right? And it's not just SunPy, but a lot of organizations, especially in a scientific field, it'll require a certain degree of domain knowledge where you need to know what, like at the beginning of your talk, you were talking about what a solar flare is and uh, monopoles and stuff like that. So how did you, were you already interested in science and that is how you got into SunPy, or was it both of these things happening at the same time, learning both software and science at the same time? How did you manage that sort of, I don't know, dichotomy?
Cool. So yeah, so you don't know need any background information on solar physics. I learned whatever I learned through my mentor during GSoC. So we had a dedicated session where he explained how solar physics in general works and how solar flares works. And I was just interested. I was curious. I've read a lot of encyclopedias, but those never go into the depth. So I just knew that solar flares are like some things going on the sun's surface where you have those loops and sometimes you screw up humanity. That's all I knew. How I learned it was, so there are two ways to go about it, and I recommend you choosing whichever you want. And you would be surprised to know that this goes for most science-related organizations. I've contributed to quite a few at this point, including having my own. And yeah, I can also tell you with regards to that. So, uh, first, get really good at Googling if you're interested in anything. It's your interest that matters more than anything else, because if you're interested, you'll figure out a way how to connect things. Secondly, software comes later for me. For me, it's better to understand what the high level requirement is, like I mentioned, what you want to do right now and why you want to do it, and then figure out how you have to do it. But you can learn it on the fly, honestly, for most organizations. This goes for Chiante Pi, that is for X-rays, SunPy, that's for solar physics, my organization, Wildfire Pi, that's for wildfire data analysis, and I think quite a few open astronomy organizations as well, including, you can also have this the same thing for SymPy, and at the same time for BioPython, if I'm not wrong. So just Google it, you'll get an overview of what you require, and then go into the code and figure it out.
Right, that makes sense. Thank you. Um, if anybody has any questions, we still have some time, but
Yeah, a good question, and this is, for so Rahul, I was in Stingray first of all, and we also dealt with X-ray astronomy. So my question is very simple. That I wanted to actually work on an ML project this year. I was actually interested in your project, but I was pretty intimidated by the fact of like everyone was saying that ML projects in GSoC are really tough. They need you to have a very deep understanding of what to do and how to do and everything of that sort. And well, maybe to some extent this is true. You to tell the audience and even me that what is the level of expertise that you need in ML or data science, or probably like is that true, like that you need a lot of experience or a hands-on experience of projects to just work on a GSoC project that is based on ML? Because I wanted to personally, but I just I was like, I'm not ready for this.
Cool. So there are two caveats to your question, whether you want to go for ML development or do you want to go for applied ML. My project was mostly applied ML, so you need to know how to use the repositories that are available. Like I use PyTorch mostly because I hate TensorFlow and PyTorch is easy. You could I also know people who actually developed code for TensorFlow and MLPack. So there you need a very high degree of software knowledge, not ML knowledge. You'll be surprised, but software knowledge, because the algorithms are out there. You have to implement them, but you have to implement them in the best way possible. In my case, you need to know how to apply and what to apply. And I don't know if it's the same for everyone, but I learned what I needed to apply in while I was just making my application. It took me a week to write my proposal. It was quite long, around 5,000-6,000 words, and I went into a very high level of granularity when it comes to the things that I wanted to do. I didn't follow anything, full disclosure, but yeah. Uh, I think even Soham mentioned this, that ML is not just using your scikit-learn and PyTorch. So if you are planning on doing machine learning projects by importing sklearn and then going sklearn.do/ml, wow, it's done. Look at all the pretty graphs. That will get you some clout on LinkedIn, but that doesn't work. What you need to understand is how things connect and why things work the way they work. I'll give you a very small insight. So when I was making the autoencoder that I mentioned, so the autoencoder was just to replicate the data set that I had and see if I could denoise it somehow. I was constantly getting very absurd results, and I had no clue why I was getting so absurd results. It took me 2 days to figure out that my dataset, because it was not JPEG images, it was FITS files. FITS files also have negative values. My autoencoder just had sigmoid activations. Sigmoid activations would shift everything from to the range 0 and 1. So everything would be positive, but my dataset had negative values. I was getting absolute shit out there. The moment I changed that to tan-h, which included for negative values, it worked flawlessly. So these are small caveats that you need to learn, but mostly this is something that you will learn after you practice and you figure out what different components are in isolation and when to use what to use, if that answers your question.
Yeah, it does. Thank you so much, Rahul.
Just to add to that, like in general, like if it's just an organization related project, or if we're talking on a small scale, uh, it might help like if you know just the software part and something like that. But like if your goal is to eventually do research in ML, I think you need to know the math underneath, and I cannot stress on this enough. And just a clarification, I did mention that you need to work on papers, but I didn't lay stress on the quality. So yeah, if it's going to be IIIE Explore papers, you might get into a good college if you're lucky. But if your goal is to really pursue PhD in a really good research lab, and if that research lab's interest intersects with yours, you need to have papers in peer-reviewed journals. Um IIIE Explore won't help you much.
Totally. And yeah, math is paramount. Fall in love with linear algebra if you want to get into machine learning. There is no other way.
Are there any other questions?
Okay, I think I do want to ask one thing to both Soham and Rahul. What was something that you weren't expecting to learn? Matlab, you didn't think that okay, this is something that I'll have to do in my GSoC thing. That definitely wasn't in your proposal, but it turned out that okay, you really had to learn this and you really had to implement something different. Was there anything like that, or I mean, the reason I'm asking this question is that uh, getting into GSoC is one thing, right? But people don't really have a clear picture of how challenging actually doing your GSoC stuff is. So, I don't know. Maybe just if you have any anecdote or anything, matlab basically anything on that.
Um, I'm not sure if this is interesting for many, but our CI was really restrictive in terms of what dependencies we could install on it, and you had to reach out to a lot of people to get something approved to be installed into CI. And we had like 33, 34 repositories with a lot of code, a lot of tests, and yeah, we wanted a slok, but slok for specific sections of code which do a certain thing, like they call certain endpoints or something like that. So we had to like we found that the best way to do that was to make ASTs, which who've not taken compiler design courses are a type of parser. These are like the type of syntax trees. Since we didn't have like the freedom to install whatever we could, we ended up coding the entire thing on Bash, something I had never imagined. It was a nightmare. Uh, but yeah, like things are possible. They might be difficult or less appealing, but there are ways to get out of things, like get your stuff done through anything as long as you have a black and white screen called terminal.
Dude, that's pretty hardcore. Not gonna lie, if you I can't make a compiler in Python. I'm failing my course this semester, and you made it in Bash. Hats off.
Dude, they had like you had to reach out like 14 people or 15 just to get a library installed. It's damn politics.
Yeah,
So yeah.
luckily we didn't have that in SunPy. So yeah, on my end, I think for me, I was under the impression initially that I'll just code up some nice neural networks and be done with it. What I initially realized was like in just the first week that we have no place to keep this code. I can't code it directly in SunPy because it's an applied project, it's not a development project. So I had to learn how to create a Python repository that is pip installable and has all the CI/CD stuff. And it may sound pretty boring, but it's actually fascinating how dependency graphs are created, how the dependencies are first collected and then installed, and not the other way around, and all these small things, and also learn talks how talks works. And these are things that really help you out later when you are in your job, because you learn best practices through these things. So yeah, software engineering won't leave you, no matter if you want to run away from it and get into ML like I did.
Okay, anybody else? I mean, I see a lot of SCs. Guys, you should have a lot of questions. So, Rahul, I'm not sure what the terminology in your college is, but SC is basically the second year students. And these are the guys who are really, I mean, they should be the most active. I'm not sure why that. I'm going to start calling you guys by your name, huh? Parth.
No man, it's fine. We call them UG2 in our college. So
Okay.
undergrad too. So even the UG2 in my college is pretty like they're low profile. I'm sure a lot of you are doing really cool things and not talking about it. But yeah, it's fine.
Yesterday, you guys, am I audible?
Yes.
So yesterday you guys said us that for now as a beginner you can participate in Hacktober, right? So I went through that website and I got to know that we have to send 4 pull requests to them, right? So I was quite worried that आज ही 11 October and the deadline is 31 and we also have term tests. So in this short period of time, how can we resolve the 4 issues? Like it's too less time for us as a beginner. I just thought that.
I
Um,
एक बस
yeah.
I just like to mention one thing here. See, term tests and all of this is just a reality of life. मतलब you just have to deal with it, and if you don't deal with it, it'll come and bite your ass later down the line. So don't ignore that. Number one. Number two, honestly, it's not as tough as you might think because, like, I remember one of my friends. So I this is not my experience. I have just started with open source, even though I'm in the third year. In my second year, I did basically nada, nothing. But on the other hand, one of my friends, I remember this very clearly, Naman Dangi. So he's in Unicode as well. So if you want, you can talk to him later on. He signed up for Hacktoberfest on, I think it was 17th or 19th of October. And within a span of 10 days, with our unit test going on, he managed to send his 4 pull requests, and those were all legitimate, proper, sizable PRs. So it's honestly not like it genuinely isn't as challenging as you might think, because a PR can be anything from a documentation contribution to like a proper extra feature entirely. So try to look for the smaller documentation ones if you want, but um, don't really think about the term test वगैरह. It's not as much of a challenge as you might think it is. Just get started once, and then the momentum will carry you forward.
And
Uh,
like
I
you don't have to wait for the entire like it's like there are many ways you can contribute all year round, right? So even if you miss Hack October Fest, like it's not a big deal. You can still get your PRs merged throughout the year. The organizations are functioning the entire year, so that shouldn't be a big deal.
Yeah, and I would like to add that so if you're not aware, there was a big controversy with Hacktoberfest this year because people just flooded random open source organizations with actual literal PRs where just they added spaces without knowing what it was, and the PR title was "Please bro, accept bro, I will get 4 t-shirts bro." No, I'll get 1 t-shirt bro. Something along those lines. I have them screenshotted, and I had a very good laugh about that. So don't do that. That's the first thing. And honestly, trust me on this. The people running these organizations are way smarter than any of us are, and they know who is contributing for the sake of contributing and because they like it, and who is contributing just to get something out of it. So if your end goal is a T-shirt, you may get a T-shirt, but you will not get anything else out of that organization. So keep that in mind. Those people are not foolish. They know your intentions.
And yeah, just don't do this for T-shirt, man. It's like it's really shame on the Indian developer side. It's
Dude.
yeah, yeah. Just don't do it, please.
60% of spam PRs were from Indians. We actually, so you can go and on GitHub and see the PRs in the last 24 or 38 hours. There was around 21,000 PRs just around 3rd of October or 2nd of October with people just messing random organizations up. You should come on Twitter and see the shitstorm erupting there. It was beautiful to watch.
Yeah, and I won't name the person, but a person did reach out to me saying if I have any repo that he can just contribute to so that he gets T-shirts. Uh, I won't name him again, but please don't do this. This is a really bad practice, and it
Yeah.
sends a really wrong kind of message throughout.
One thing I would like to mention here is I'm a big critic of the Indian education system in the sense that and I understand that we have a large population and it's survival of the fittest because that's the only way this country can function. But open source is not something like your entrance exams were. Don't take it as JE that you have to crack. And I really hate the word crack. There's nothing to crack here. Don't game the system. Don't try to find, ways to get in and wiggle in and figure out how to get things done without actually doing what it is. So we have a very beautiful word in Hindi, जुगाड़. जुगाड़ मत करना बस. जुगाड़ किसी को नहीं चाहिए. What they want is actual shit done in a proper way. And the only way to do it is to love what you're doing. This is not your JE. You're not fighting against anyone else. No one is there to take your spot. They will come to you, and you will be surprised how good people are when it comes to open source. I've literally found the best people I know through open source.
Okay, then if those are all the questions that we have, I think we can call it a day. Yeah, so if anybody has any questions, it's the last call. Um, nope. Okay, then. Thank you, Soham. Thank you, Rahul. Thank you to Synapse and Unicode as well for putting this entire thing together. We look forward to having more such events. I mean, we're trying to, sort of organize more events, get more community outreach, and get our college students and maybe even from other colleges, people really active into open source and stuff like that. So keep your eyes peeled. We'll definitely have more such events coming up. And yep, thank you. You guys can reach out to Rahul and Soham and Amog and anybody else you'd like to. They have their. We'll send the message again on the group. Their LinkedIn profiles and stuff like that. Obviously, don't spam them, please. I'm not saying that you should just blindly message them. But yeah, I think they'll be more than happy to answer your questions or doubts if you have any. Um, I think that's it. Thank you guys. Thank you so much for coming, and see you whenever the next event is. Bye bye.
Cool. Thanks, guys. Thanks for inviting me.
Thank you.